What's up, calculus students? Last homework on a lesson. We start reviewing. This is it. Toughest lesson of this unit. We are going to take regions. We're going to spin the region around an axis. When we spin it around the axis, it creates this kind of reflection, this three-dimensional object. You got to find the volume of the object. It might seem very crazy, but if we use our friend the rectangle, it's not going to be that bad. Because we should know that a rectangle, when a rectangle is spun, here is a rectangle. When the rectangle is spun, it creates a cylinder. Let me get my CD. Okay. So, cylinders, based on starting with rectangles and spinning them, makes like a tire. Okay. Now, the volume of a cylinder is very simple. It's pi r squared h. But let's take a rectangle, spin it. This rectangle has this x length and this y height. If I spin it, what I realize is that the x length ends up being of the tire that's created, the cylinder that looks like a tire. The x length is the height. The y length ends up being the radius. Because we spin this around, this length ends up being the radius after spun around completely. It's the radius of my tire. This is the height or the width of my tire. So the volume of that rectangle is pi y squared x. But what if I take this rectangle and make it very, very skinny? Okay, just take the rectangle and make it very, very skinny. This is a very skinny rectangle. You can kind of see it here. If you spin it, it still creates a cylinder. We still have a y distance, but the height, this x distance, is a very small x. So all of a sudden, we get the idea of pi y squared dx as being the volume of this skinny rectangle being spun, which creates this skinny tire. It's like a CD. Here is the rectangle's height. Here is its skinny width, dx. It's not a big x distance. See this big x distance? It's not this big x distance. It's this very, very skinny x distance. This was the radius of my, this is the height of my rectangle, which spun becomes a radius. This is the skinny width. If I did it in the opposite direction, many of us were good with this during class if you were here. You start with this x and this y. If you spin it this way, you create a tire that's like resting on the floor, whose volume is pi r squared. R is now x. H is y. If you make it a skinny rectangle, well, you'll have x squared, but the y is very skinny. Again, if you orient it this way and we spin it this way, we have this x distance, which is the radius after we spin it. And then this y distance is going to be the height of my cylinder. If I smush it, here is a smushed rectangle that is spun. We can see it creates this cylinder. X distance here is my radius. Small y distance is the height. To find the volume of the rotated area, what are we doing? Well, what we're going to do is we're going to bind our friend, Mr. Rectangle, who's skinny, and We're going to sum up an infinite amount of the rectangles getting spun. We're going to use our friend Mr. Integral, Mr. Sum. We're going to sum up all these pi r squared h's, where this is x or y and this is dx or dy, depending on the situation. All right, so let's do it. Things get complicated when we see there's negative spaces, there's like holes, and things get complicated when we spin around other axes besides the x or y axis. So we're going to start with easy ones. You need to type this into your calculator as well, but that's not the important thing. I'm not going to spend time typing into calculators. I'm going to spend time just setting up the integrals. And for those that I ask you to do it without a calculator, make sure you can do it without a calculator. I'm spinning this region around the x-axis. Recommendations, what you have to do if you want to be successful. Draw the reflection, understand the object. Does it have negative space or not? If it does not have negative space, then just you have one set of rectangles being spun, which will create one set of cylinders, which you will sum up. We could see this is a y distance. We could see this is a skinny x distance. We will sum up our pi r squareds h's. H is the skinny width. X is the skinny width. It's going to be the height of the cylinder after you spun it, the height of your tire. And then the r is this y distance that's spun, which is 9 minus x squared. Make sure we sum vertical things up from an x equals left to an x equals right. I don't give it to you, but it's there. X equals 0, and then 1 does 9 minus x squared equals 0 when x is 3. Okay? Don't forget your pi. The squaring of our radiuses is different than our volumes of known cross sections, and you'll see that. What if I spin things around the y-axis? Well, I'm going to take a horizontal rectangle, spin that, sum up all of those. We can see this is an x equals distance. This is a small y distance. I will sum up from a y equals bottom to a y equals top. How do I know that it's 9? Because I plug in 0. This is an x equals to an x equals of pi r squared h. My r is my x distance. My x distance is a right minus left, and x equals, I need to solve my equation for x. Add x squared, subtract y. X equals plus or minus root 9 minus y, but if we're in the first quadrant, you'll always have the positive. Now, just getting us ready for our test. If this was no calculator, what would you have to do? If you had a calculator, you type this in. If you had a calculator, you type this in. I can type this into my calculator. I'll do this for this example, and then I gotta just get through this homework. Might be easier to worry about the pi's later. Don't forget to multiply by pi. You get your answer. Again, if you have a calculator, just type it in. You could put the pi inside. You have to practice using parentheses. You got to make sure you square it. Typing things into calculators sometimes can be tricky. But if I did not have a calculator, what do? I look to take the antiderivative. I can't take the antiderivative of this. I'm going to have to simplify first. This is 81 minus 18x squared plus x to the fourth. You don't square this by doing 9 squared and then x squared squared. That's not how it works. We know that. Multiply 9 minus x by 9 minus x squared by 9 minus x squared. Now we take the antiderivative. The c is going to go away. We can leave our answer unsimplified. Okay, that's correct. That's fine. I'm going to be able to check. 81 times 3 minus 6 times 3 cubed plus 1/5, 3 to the 5th. That should work out. 129.6 times pi is just what I got earlier. Okay, and then if we were to do this one without a calculator, simplify is easy to do. You get 0 to 9 of pi. This just becomes 9 minus y. It's very easy to do. We take the antiderivative. I get the pi, which we don't take the antiderivative of. The pi can be left out. Constants you don't have to worry about. If they're constants times, constants plus, we do. So since it's pi times, I don't have to worry about it. I just take the antiderivative, plug in 0, plug in 9, and that'll be my answer. So this is 81 halves pi. Okay, 127.234. All right, next one is tricky. You have to have the visualization. Here's where everybody goes wrong. We're spinning this around x equals 4. Whoa. If this is spun around x equals 4, it's not going this way. It's not going this way. It's going that way. We can see it creates this solid object. I will draw one rectangle being spun. I will notice the x distance, which is my radius. I will notice the y distance is my height. It's skinny. I will sum up my pi r squared h's. The height of your cylinder is always the skinny part of your tire. Think of it as like a road bike tire that's very skinny. A road bike tire, in this case, on the floor. Skinny height, y distance. Long radius, x distance. What is this x distance? Well, this x distance is an x equals middle minus an x equals left. Very hard to see it. You have to like try and be like, where is the radius? Where do I see the radius? Right there. X equals right minus x equals left. Sum them up from a y equals 0 to a y equals, plug in 4, you get 2. Plug it into your calculator. What if this region is evolved around the x-axis? This one will be a little bit easier. You got to draw it, though. You could see, okay, it does create this solid object, and we have these rectangles being spun. They have a y equals distance, that's a radius. They have this very small x distance. So I'll sum up my pi r squared h's here. My h is a small x distance. It's like the small x distance, which ends up being like the width of your tire, which is the height of your cylinder. And the y equals distance is y equals root x. From an x equals left to an x equals right. Okay. X squared, y equals 0, x equals 2, revolved around the x-axis. Another easy one. Here is my radius. It's a y equals distance. Sum up pi r squared h, skinny x distance, width of the rectangle is very skinny, y distance is y equals x squared. We're going from 0 to 2, x equals 0 to x equals 2. Without a calculator, okay, we're ready for this. This is easy. Simplify, maybe pull out the pi, plug in 0 and 2, multiply by pi. If you had a calculator, you just type it in. No calculator, get that. Okay, one more solid object, then we got to make them harder. These are the easy ones. If you feel like, okay, I got this, and then you're going to copy down the rest of your homework, don't do that. If I'm revolving around this x equals 2 axis, it makes sense to use this horizontal rectangle being spun, which has this x equals distance that goes from the middle to the outside. It's got a very small y distance. Sum up my pi r squared h's. The h is the very small y distance. Do it from a y equals bottom to a y equals top. Where's the y equals top? If I plug in 2, I get 4. What is the x distance? Well, you can see the radius of this cylinder is an x equals 2 to an x equals, well, it's y equals x squared, so that's an x equals root y. 2 minus root y. Okay? If you want to do this without a calculator, it will suck, but you can do it. Simplify. Pull out the pi, take the antiderivative. Don't worry about it being perfect as long as you have the correct antiderivative, and then you plug in 4 and 0, you're good. That's fine. All right. First 2 pages, solid objects. Rest of the homework, objects with holes. Okay? There's 2 different ways to find the volume of a region spun that creates this hole. Okay? And here's what everybody thinks of doing, and they're always wrong. They always think, okay, well, there is my rectangle. And if I spin this around the x-axis, here is my rectangle kind of being spun. Cool. Intersection, this is at 3, this is at 9. You can use your calculator for that, or just I'll tell you on the test. This is 0, 0. Many people think the following. They think, okay, pi r squared h. And they're like, the radius must be this y equals top minus the y equals bottom. You're wrong. You're wrong. It's different than what we were doing last class. The volume of what ends up being like a washer or a CD, where you have a hole in the middle, the volume of this CD is not top minus bottom squared times pi times h. So here's what I recommend doing. And we will use these purple washers, and I'll show you the formula for the volume of a washer in a second. Okay. I'm going to start by visualizing 2 sets of cylinders. So that's bad. Here's my visualization of 2 sets of cylinders. I have one rectangle being spun that's going to go to the outside, and we're going to sum up all of these outside rectangles being spun. And then I have one that goes to the inside. We're going to sum up all of these inner ones. I can see if I take the red cylinders and subtract the blue cylinders, I'll get my object. This is the two integral approach. The two integral approach is taking the volume all the way to the outside and subtracting the volume of the inside. The volume of the outside here uses the radiuses y equals 3x minus 0. I don't have to put the minus 0, but I'm going to put it. Okay? Skinny width dx. These are my red cylinders. My blue cylinders have a radius of y equals x squared. No matter where I am, I'm going to y equals x squared. So I got x squared minus 0 squared. And this is correct. This is the two integral approach where you're looking at outsides and insides. But here is the one integral approach, which turns out is the volume formula for a washer that is a rectangle being spun that has a hole in the middle. The volume of this washer, I don't want you to use the washer until you understand the two integral approach. And what do I mean by a washer? I mean like the things that you use to like tighten in screws. You know, that a CD, a tire. You have the pi factored out. You have the dx factored out. And it's not top minus bottom squared. Wrong, 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 wrong. Rather, it's outside radiuses squared minus inside radiuses squared. This and this are not the same. Many of you who don't know what you're doing, you were kind of understating things earlier. You don't really watch this lesson. You will do this. You will be wrong. You might say they're equal. They're not equal. They're not the same thing, so you're wrong. Okay. What happens if we revolve things around different lines, like y equals negative 2? Well, all of a sudden, our radiuses need to get adjusted. I'm going to show you the two integral approach and then the one integral approach. Here we go. Let's go all the way to the outside. This is my red cylinders. Sum up all of my red cylinders. I'll get the volume of everything. The red cylinders have a radius that I'm going to tick off right there. What is that radius? It is a y equals top minus a y equals middle. I have to adjust my radiuses because I'm spinning around this y equals negative 2 axis. Don't forget to square dx. We're summing up from 0 to 3. Cool. Outside minus blue cylinders to the inside. We have to adjust. Now, you don't have to draw a bunch of them. Just draw one, but understand, maybe drawing a bunch of them, you see that you got to sum it up from an x equals left to an x equals right. 0 to 3, I'm subtracting this. X squared minus negative 2. That's adding 2. That's extending my radius. We're good. This is the two integral approach. If you want to think about the washer, which is this rectangle getting spun, well, what's important is you got to realize that the radius is going to the top and the middle and the bottom and the middle. The one integral approach, the tire approach, the approach of a rectangle getting spun that will have a hole in the middle. The CD approach is that you got to take your outer radius squared and then subtract your inner radius squared. It's not top minus bottom squared. I got to say that over and over and over again. It is not top minus bottom squared. It's outer radiuses squared minus inner radiuses squared. Outside, inside. Why we say out and in instead of top minus bottom is because look at what's going to happen here. If I revolve this around y equals 10, things change. This is why it's so important to kind of sketch this reflection. If you want to, what I advise you to do, notice that to the outside, we are going off of this y equals 10, which I don't know the equation up here. A lot of you like to go to the top, but I don't know the equation of that up there. Okay, I know it's y equals x squared reflected, and it's above y equals 10, but I don't know the equation. So I'm going to go to the middle and say that's like the top of my radius, and this is the bottom of my radius. Many of us don't understand or don't see why we should be going middle to bottom. This is an equation I know. This is an equation I know. This is my radius. This is the first one that is going to be challenging many of you. Blue cylinders going to the inside. Middle to the bottom ends up being y equals 10 and y equals 3x. That's the radius. Sum up my red cylinders. Now here's important. We always think it's y equals top minus y equals bottom. It's not that. Look, the outside goes to x squared. We got a pi, r squared, but my r's to the outside are 10 minus x squared. And then the blue cylinder's radiuses is 10 minus 3x. This is the two integral approach where you're doing outsides and insides. If you want to do the washer approach, you're taking this rectangle, spinning it. Understand that the radius is affected by that 10. Understand from the y equals 10 kind of spoke that this rectangle is being spun around to create this tire that just has like the rubber outside, that the outer radius is 10 minus x squared and the inner radius is 10 minus 3x. Make sure you don't do top minus bottom. Make sure you don't do 10 minus top minus bottom. Make sure if you're going to do this tire CD washer approach, you do outer radius is squared minus inner radius is squared. You can see it's the same as what we have up there. It's just like with one integral instead of two. It's like they're equivalent. You're going to type it into your calculator. You need a big set of parentheses. Now it gets harder because I'm going to revolve it around this x equals 4 axis. Now, a lot of you are like, what's the answer? It's like, I can't. Like, I'm not going to spend time typing it into my calculator. It takes too long. We will get answers in class, but like, make sure we get the setup. And then if we need to practice typing things into our calculator in class, we got to do that. Okay. When this gets spun around this axis, this region gets reflected over here. You got to draw this. You have to either, after doing it a bunch of times, draw your horizontal rectangle being spun around this axis, creating outer radiuses and inner radiuses. If you don't get that, two integrals, red, blue, to the outside minus the inside, object minus whole. These are x distances from an x equals 4 minus an x equals y over 3. This is an x equals 4 minus an x equals root y. So red, we're going from y equals bottom to y equals top. A lot of people really screw up on the boundaries because they're not thinking about that way. X equals middle minus x equals left in this situation. The red cylinders go to the 3x. So I'm going to do 4 minus x equals y over 3. x equals 4 minus x equals root y. If you are just copying down, you are not actually knowing what you're doing, and you're just guessing out there. You need to try the next one by yourself if you're just copying this down. If I were to do the washer approach, here's that rectangle getting spun over here. Here's the radius to the outside, 4 minus x equals y over 3. I'm going to factor out the pi. And then middle to the inside, you get that. So it is a new formula to kind of know the volume of a washer formula, which I'll put down up here, but like the volume of a CD slash washer, like used in construction slash tire with rubber on the outside, is pi. Outer radius is squared minus inner radius is squared, h. All right, x equals -1 is over here. We're going to pop over here. You have to draw this. I'm going to try to do it one more time, and then I'm going to, the next one, I'm just going to do the washer approach. Outer radiuses, outside object, x equals middle to x equals right are the two equations that I know. Inner objects, x equals middle to x equals right. You want the two integral approach. This is a small y distance. This is a horizontal thing. We should sum it up from a y equals bottom to a y equals top. Many of you are struggling with that if you don't understand why we take horizontal things and go from the bottom to the top. You don't understand the whole paint the fence thing. It's x equals middle minus x equals left. Now, many of you might be putting it in the opposite order, root y minus -1. It'll work out. You'll get the right answer. Why are you going to get the right answer? Because we're squaring our radiuses. We don't care if our radiuses are positive or negative because they will be squared. This is an x equals distance. This is an x equals distance. You got to really understand that. You got to sum them up from a y equals bottom to a y equals top. If you want to do the washer approach, it's not a right minus left squared. It's an outside radius squared, an inside radius squared. You got to see the outer radius. There's my outer radius. There's my inner radius. Maybe that works. Outer radius is root. Wait, I did this in the wrong direction. Like, look, I even said middle minus right. That's not right. That's going to be a negative radius. This is correct. This is correct. But no, I wouldn't do it this way. The correct way would be root y minus -1. And the correct way would be y over 3 minus -1. But it doesn't matter. Just make sure you square it. Here, yeah, right minus left, right minus middle, outer radius is squared minus inner radius is squared. dy, skinny height. All right. This one's fun because a lot of people get confused with this x equals 4 and how that plays out. You gotta visualize it. Here's my region. Here's x equals -1. Here's my region being spun. Here is my washer. But the outer radius of my washer would be x equals 4 minus x equals negative 1. The inner radius of my washer is x equals y squared to x equals negative 1. The setup for this, we're summing up horizontal things from a bottom to a top. This is y equals 0 to y equals 2. How do I know it's y equals 2? Plug in x equals 4. Outer radius is squared. X equals 4 minus x equals negative 1. Inner radius is squared. X equals y squared minus x equals negative 1. Cool. X equals 5. Let's just show it up here. I'm going to use one washer. I'm going to spin this one washer. I'm going to use this one rectangle. Spun this one rectangle creates one washer. We have outer radiuses of my washer, my tire. We have inner radiuses. I'm going to show if you use two sets of integrals, the red radius is that length. That'll go to the outside. The blue radius is this length. That'll go to the inside. We're going to sum these up from a bottom to a top. Y equals bottom to a y equals top. We'll pull out the pi. The outer radiuses, this is x equals 5, would be 5, x equals middle minus x equals left, minus y squared. Subtracting the inner radiuses would be 5 minus 4 squared. Okay, y equals 3. Draw the reflection. Draw two sets of rectangles, outers and inners, or one rectangle getting spun to create a washer, tire, but understand it's not going to be top minus bottom. We're going to have the outer radiuses and the inner radiuses of my tire. Here are the outer radiuses, the red radiuses. Here are the inner radiuses. Okay, good picture. Now we got to be able to do it. We got x equals 0 to x equals 4. We got this vertical thing. We want to sum it up from x equals left to x equals right. The outer radiuses, those red radiuses, squared minus the inner radiuses squared times their skinny height. The outer radiuses are this minus this. Well, that's y equals 3 minus y equals 0. This like middle minus bottom. I'm not going to go up here because I don't know the equations up there. What are the blue radiuses? 3 minus root x. Realize I never do a top minus bottom squared for this situation. Never. I always do the axis that we're revolving around minus one of the functions squared. And then another axis we're revolving around minus the other function squared. It's never top minus bottom squared. Y equals negative 3. I will take one rectangle. I will spin that, creating a tire, rubber outside, hole in the middle. The formula for the volume of that tire, the volume of this CD, just trying to get this through your brains, is not pi top minus bottom squared, but pi outer radius is squared minus inner radius is squared times h. If we're talking about a very skinny tire that's rolling around, Well, the h is dx in this situation. If the tire falls on the ground, then the h is dy. We will sum this up from an x equals left to an x equals right. Here are the outer radiuses. Here are the inner radiuses. I'm not going to go off of the bottom. I don't know the equations. This is y equals -3. This is y equals root x. This is y equals 0. Outer radiuses, root x minus -3 or plus 3. Inner radiuses, 0 minus -3 or just 3. Very skinny x width. These are good. If I spin this region around the y-axis, pops over here, I can see I create a solid object. Okay, cool. This rectangle being spun means I don't have to worry about holes. I don't have to have outsides and insides. I just have one outside. This is x equals 10 over y. This is an x equals distance. It's got a skinny y height. I will sum up from a bottom to a top. My pi, r squareds, 10 over y minus 0, h. Done. But why is the x-axis not as easy? And you will have one challenging question like this on your test. Put it on a multiple choice part. See if you can figure it out. You have two sets of washers. You have potentially 3 or 4 integrals that you could have. You have this set, which has these 2 radii, outer radii, inner radii. But then once you get here, things change. This intersection right here, we change the type of rectangle that gets spun. Here, outer radii, inner radii are different. That was the worst bracket I've ever made in my life. Okay. Where do we intersect? We intersect at x equals 1. We go to x equals 5. How do I know that? I just figured it out. Just plug in 10, solve for x. Plug in 2 for y, solve for x. Ready? We got 0 to 1, first set of washers. We got 1 to 5, second set of washers. My first set of washers, my first tire, has an outer radius of 10, 10 minus 0, an inner radius of 2, 2 minus 0, skinny x distance, left and right. But from 1 to 5, the outer radius is 10 over x minus 0. The inner radius is 2. This could have also been done if you did the following. 0 to 1 of your outer radius is squared, 10, plus 1 to 5 of your inner radius, or of your outer radius is squared again, and then subtract 0 to 5, those inner radiuses. You can see I subtracted from 0 to 1 and subtracted from 1 to 5. We could have just subtracted all of it from 0 to 5 and think about it separately. Okay, revolving this around x equals 4. If I revolve this around x equals 4, it's going to look like this and look like this. I'm going to take one washer, spin it. I'm spinning it around this axis, creating this. You do your homework, okay?
I did.
You already did it?
Yeah, I did. I like that.
We can see this outer radius. We can see this inner radius. However, the outer radius is an x equals distance. The inner radius is an x equals distance. I need this x equals y squared. I need this x equals 2 minus y. Also need to figure out when they intersect. Probably could have told you, and I probably will tell you, that's going to be at y equals 1. Sum up from 0 to y equals 1. Outer radius is squared minus inner radius is squared. dy, skinny y distance. It's the tire on its side. That's probably going to be tough to type in your calculator. If you try. Why is this not as easy? Oh, geez, y equals 4. If I'm spinning this region around y equals 4, it's going to pop up here. I can see I have 2 sets of washers needed, 2 sets of rectangles that need to be spun. I need to pay attention to this intersection, which is at x equals 1. This is going to be at x equals 2. This is going to be at x equals 0. And I need to understand the radiuses. The radius is actually going to be 4 to the outside the entire time. Why don't we do this like the following? Let's go from 0 to 2 of pi. Outer radius is squared. That covers everything. Skinny x distance. What are my inner radiuses? Well, my inner radiuses change. So I'll need to subtract from 0 to 1 my inner radiuses, which is 4 minus, this is a y distance, this is a y equals distance, this is a y equals root x. And I also need to subtract from 1 to 2 my 4 minus 2 minus x radiuses. You could have had this as just 2 integrals, where you're going from 0 to 1 of 4 squared minus 4 minus root x squared. And then from 1 to 2, don't forget about your pi, you have 4 squared minus 4 minus 2 minus x squared. Okay. How many integrals do you need to spin this around the x-axis? Well, it all depends. I can see I need 1 set of washers, 2 set of washers, 3 sets of washers, because my outer radiuses change. You need at least 3. 3 set of washers, you could do 4 integrals. 3 integrals is fine. You could do 4 integrals. 4 integrals would be outside, outside, outside minus inside. The inside is consistent. Or you do outer radius minus inner radius. Outer radius minus inner radius squared. Outer radius squared minus inner radius squared. So I'm revolving this around the y-axis. I only need 1. because if I'm spinning this around the y-axis, I see the right and the left, the outside and the inside will stay consistent. The outside is always going to go to 7 minus x. Those are the outer radiuses. The inner radiuses are always going to go to the x squared. Yo, do this. Do this yourself. I'm not going to show you how to get the answer. I'm going to write down the answer so you can check. But you need to try this yourself. I'm just going to do this in my head. I've done this enough in my head that I can do this. I can see the washers in my head. This is the cosine graph. That's the h of x. Those are my outer radiuses. These are my inner radiuses. Skinny x distance. Let me just show you the idea, the simple idea, which I don't recommend unless you know what you're doing. There's my rectangle spun around this y equals 6 axis, creates this outer radius and this inner radius. 6 minus g, 6 minus h. This rectangle being spun creates a washer. Don't do top minus bottom squared. Outer radiuses, inner radiuses. Are they telling us where they intersect? I'm going to just call this A. Find the intersection. Outer radiuses is consistently y equals top minus y equals middle. Inner radiuses, don't forget to square, are consistently f of x minus negative 2. So minus a negative 2, we are extending the radius, we're making it bigger. That's what it is. Y equals 4. Here's my washer. My rectangle spun, creating a washer. It'll end up over here, the radius to the outside. That guy, the radius to the inside. That guy. It's not top minus bottom squared. It's outside squared minus inside squared. Which one's which? This is going to be f of x. This is g of x. 0 to 2, from x equals left to x equals right. Outer radius is middle minus the f of x. So this is y equals 4. 4 minus f of x squared. Inner radius is 4 minus g of x squared. It's really the same thing. This is f of x, this is g of x. This also shows you don't have to write out the entire equation. You don't have to evaluate a lot of times. You're just going to have to write it out. There's my rectangle. Spin around this axis, creates 2 sets of radii, an outer set of radii and an inner set of radii. These are y equals distances. We'll sum it up from 0 to a half. That's the x equals left to an x equals right. Outer radiuses are 1 minus f squared. The inner radiuses are 1 minus g squared. Let's skip the y equals 7. Let's just do the x equals 10. I will take a horizontal rectangle, spin that to create this horizontal tire. It's tire on this side. 2 radiuses going to the inside of the tire and then the outside of the tire, where it's a true CD. There's the outer radiuses. Here are the inner radiuses. These radii are x equals distances. X equals 10. X equals 10 minus, what is this? Y squared over 4. X equals 10 minus y squared over 4. Sum these up. It's a very small y distance. The y distance is the height of the tire. Sum these up from a y equals bottom to a y equals top. Don't screw that up. Okay? That's it. Hopefully you understood. Test coming up. Last unit test of the year. Mr. Messner is out.